Okay, there are some integrals that can be worked out and brought down to integration of rational fractions. So, which types of integrals can be worked out by using the method of integration of rational fractions? Those are, if we have function of e to power x dx, if we have integral of function of radicals ax plus b, let's say to power m over n, ax plus b, as you can see, same base, but degrees is going to be different, rational degree, n over s, ax plus b to power p to over q, and at the end will be left x, let's say, and dx. The other type of integral that can be worked out and brought down to integration of rational fraction is going to be integral of function of sine x and cosine x dx, function of cosine nx times, it's a product of cosine mx, coefficient has to be different. Accordingly, it's going to be integral of sine nx times sine mx dx, and a combination of sine and cosine, sine x times cosine x dx, and lastly combination of sine cosine with some degree, sine degree n x times cosine degree m x dx. Okay, so we start with function of e of x, and I'm going to cover every single type of it, and all of them will be worked out to bring down to using the method of rational fraction. All right. Let's assume we have integral, problem number 1, e of x, e to power x plus 1, e to power 2x plus 4 e to power x plus 4 and dx. Okay, so we need to do substitution, and substitution is going to be e to power x is equal t. Yes, so if e to power x is equal t, based on definition of logarithm, x is going to be equal natural logarithm t. Yes, because base is e, which means we can take natural logarithm. Natural logarithm usually has, not usually, well, it has base e. We don't put it because natural logarithm means that the base is e. Okay, and dx going to be derivative of logarithm t, which is going to be d1 over t, right? dt. let me write down here natural logarithm x prime is equal 1 over x. Okay? All right. So let's start working. We are going to get integral t plus 1. Denominator we are getting t squared plus 4t plus 4. Look, we are getting perfect square, right? And dt over t, right? Okay, so this is going to be equal integral t plus 1. Here we are going to have t plus 2 squared. It's a perfect square, guys. T plus 2 squared times t, and here dt. We have here perfect square, a squared. Okay. I don't know why I keep using this thick one. Okay, if this is a squared, this is my b squared, which is 2 squared, and here is 2ab, right? And we get t plus 2 squared. All right, so, well, now I can apply, represent the expression or rational fraction under the sign of integral, represent in the form of rational simpler rational fraction. And as we can see, it's a proper fraction because highest degree of numerator is 1, highest degree of denominator is 2. Okay, now let me remind you, it's a different story if in denominator I have t plus 2 squared, or if I have t squared plus 2. If I have t squared plus 2, then in numerator I will end up having ax plus b, because I have here degree, a t plus b, let's say. Because I have here degree 2, that's mean in numerator I have by 1 degree lower plus 1. If I have, let's say if I would have here t cubed plus 2, then I will have a t squared plus bt plus c. You see that? Quadratic expression. But because I have t plus 2 squared, I can rewrite it. It can be either t plus 1, or it can be t plus 1, t plus 2 or t plus 2 squared. Yes? Let me rewrite here. It's either t plus 2 or t plus 2 squared. Correct? Therefore, it's going to be, here it's going to be a, here it's going to be b, because degree 1, that's mean this t plus 2 squared is 2 of them, t plus 2, right? That's why it's degree 1 we're taking. Therefore, it has the highest degree numerator has to be 0, which is t to power 0. Or we don't put anything there. Are we clear? Okay. Let me clean this. Because this is sometimes confusing. Students don't know when to put ax plus b, when to put just a, when to put quadratic expression ax squared plus bx plus c. So now you know. All right. So, moving on. I'm taking the expression, rational expression, t plus 1 over t plus 2 squared times t. Now it's going to be equal now this time I'm going backwards, t plus 2 squared, and then I'm taking b over t plus 2, right? Because t plus 2 squared it includes n squared, t plus 2, and t plus 2 squared, because we don't know which one it is. So we are showing both elements. And plus c, we have the c over t. Okay, so now we need to find out our unknown coefficients a, b, and c. Bringing to a common denominator, we are going to have, and common denominator is going to be what? It's going to be t plus 2 squared and times t, yes? Which means I can drop this denominator on the left side, and I will have t plus 1. And on the right side, I will have a t, right? Because I have t plus 2 squared already. All I have to do, multiply by t, plus b times t plus 2, because I have only degree 1. T plus 2, I need squared, so I am multiplying by t plus 2, and then times t, and plus c times t plus 2 squared. Okay, now let's find coefficient a, b, and c. And I'm going to use both ways. One with assigning some value to t, and the other one is solving as a system of equations, okay? So you can see both ways and make your own choice which way you want to go. So, let's assume I'm taking t is equal 0. My t is equal 0. So from here, what do we get? On the left side, I have 1. On the right side, it's going to be a times 0, right? Plus b times 0 plus 2 times 0, right? And plus c times 0 plus 2 squared. So we have only 1, c is equal, 1 is equal 4c, and c is equal 1/4. Yes? Okay. That's first one. Okay, I don't want to get out of half of the page because I want to do it parallel next. Okay. So c is equal 1/4. Next one. Let's say I'm looking what value I can take t, because I need to find a. So the best way to get rid of b and c, accept t is equal -2, right? And that's exactly what I will do. T is equal -2. On the left side, I will have -2 plus 1. On the right side, I will have -2a. And then plus b times 0 plus c times 0. And -1 is equal to -2a. Yes? And a is equal 1/2. All right. So I have a, I have c. Now I need to figure out b. So obviously, since we have already a and c values, I'm going to plug value a and c also. So it will be easy to find out our value b. So let me see. Since my a is 1/2, c is 1/4, it's 2 fractions. I'm going to pick my t as a 4. So when I multiply, I can get, in the case of c, it's 1/4. I can cancel. In the case of a, 1/2. 4 divided by 2. So I'm taking 4. T is equal 4. So what do I get? 4 plus 1 is equal 1/2 times 4 plus b, I don't know, I'm leaving alone. 4 plus 2 times 4, and plus 1/4, that's the value of c, right? And 4 plus 2 squared. Okay, So what do I get? 5 is equal 2 plus 24b and plus 9, right? Meaning 1/4 times 4 plus 2 is 6. 6 squared, 36. So this is 1 and this is 9. Okay, so and the next step we are going to have 5 minus 2 minus 9 is equal 24b. So negative 6 is equal 24b and b is equal negative 1/4. Okay, so this is we solved this way, found values a, b, and c. All right, now let's find out with method of system of equation. All right, so what we're gonna do here in this case, I'm going to multiply, open all these parentheses here. It's going to be a long way, so which is clearly the method I just used it's going to have advantage. But let's solve it so you can see. T plus 1 is equal AT plus B T squared plus 2BT. Next, plus, since we are going to use t plus 2 squared, which is going to be t squared plus 4t plus 4, right? So all I'm going to do, add their c next to it. It's going to be, let me put this b more expressive. There we go. So plus, it's going to be c t squared plus c times 4, okay, 4ct, so 4ct and plus 4c. Okay, so what do we have here? We have bt squared, ct squared, and then we have at, 2bt, and 4ct. And we have only 4c that doesn't have any term with which it would have common factor. So I'm going to put a double at the wavy sign. Okay, so bt squared, ct squared, since I don't have on the left side t squared, which is means I have 0 times t squared, correct? Okay, so I'm going to write down coefficient of this t squared is going to be b, plus coefficient of this t squared is going to be c, and this is going to be equal 0, right? All I did, it just took out t squared, and here 0 times t squared, right? I am matching the coefficients. T squared we have here, and t squared we have this one and this one, which means b plus c is equal 0. Let me take this parenthesis, we don't need it. Okay. Next. Next, with 1t, we have at, 2bt, and we have 4c, which is going to be a plus 2b plus 4c, and on the left side, coefficient of t is 1. Yes? And 4c, it doesn't have any common factor with any other term, is equal, it's available term. On the left side, my available term is 1. Okay, so I need to solve this system of equation. So we need to solve it. If 4c is equal 1, Then from here, c is equal 1/4, correct? So I'm going to plug to first one, first, second, third. I'm going to do method of substitution. So I'm plugging to first one. And we have b plus c equals 0. And I'm having b plus 1/4 is equal 0. And from here, b is equal negative 1/4. Okay, so next we have left to find a. To find a, I'm going to plug to second one, which I have a plus 2 times b. b is negative 1/4. And then plus 4 times c is 4 times 1/4. And it's equal 1. We are getting 2 minus 1/2 plus 1 is equal 1, right? This 1 and 1 we can cancel because they will cancel each other. And I have a is equal positive 1/2. Now let's compare to what we have. A is equal here on this side 1/2. And here we have also a is equal 1/2. So I got here b is equal negative 1/4. Here is also I got b is equal negative 1/4. And c is equal 1/4. And here it is my c, 1/4. Okay, we got values of coefficients and I showed you both methods. So this is the only time also I did it, so you make sure you understand how to use each one of them, and it's a matter of your choice. But from now on, I'll just use the method I like. If the calculation is a little bit complicated, with too many multiplications, then I'm going to use method of assigning values. If not, then system of equations. So it's based on what I see, I can decide which way I want to go. But one way or another, you are not going to be wrong. All right, so from here, what we have, let me write down my original problem one more time. Integral, we have t plus 1, remember, over t plus 2 square t dt. So we are getting, we had a plus b plus c. Okay, let me write down. A over t plus 2 squared plus b t plus 1 and plus c t. Okay, so from here we have integral. A is 1/2, right? 1/2 t plus 2 squared dt plus b is negative 1/4. Okay, let me write down just like that. 1/4 t plus 1 dt and plus c is the 1/4, so it's going to be integral 1/4 t and dt. So what do we get from here? With method of substitution, t plus 2 squared, and I have used it before, so you already, I'm pretty sure you know. So t plus 2 I put as a u, and u squared will become u to power negative 2, right? Take derivative in you'll get the following result. So you're gonna get the first one, it's gonna get, because you substitute u to power negative 2, then negative sign is gonna pop up, and we're gonna get equal negative 1 over 2 t plus 2. Substitute t plus 2 as a u and you will get this answer. Minus 1/4, this is clearly natural log. You don't need to substitute here. T plus 2, oh, t plus 2. Okay, for whoever is always watching my videos or already getting used to it. So 1 and 2 I can confuse. So, and you know, I will come back and fix it. Okay, t plus 2 and plus 1/4 natural log t. Yes, and plus c. Because we don't know, can be constant, and derivative of constant is 0. So because we can't see it under integral, therefore we always, to be safe, put this c. All right, bringing back e to power x, remember we had t is equal e to power x, right? Substitution, bringing back, and we are getting negative. The answer practically is going to be negative 1 over twice e to power x plus 2 minus 1 over 4 natural logarithm e to power x plus 2. Okay, here I don't have to put absolute value because I have e to power x, which is going to be always plus 2 positive. So I'm going to put parentheses and not to worry about absolute value, and plus 1/4 of x. Yes, and plus c. I'm sure some of you are wondering, how so logarithm e to power x, we got x? Very easy. Okay. Logarithm, natural logarithm, e to power x. Here I have e, right? If I have, say, natural logarithm, that's mean my base is e. So what value has to be here? So I raise it here and get e to power x. Obviously it's going to be x, right? Because e to power x, I will get e to power x. Very easy, right? Definition of logarithm. Therefore, we will end up with x. Okay. Moving to next one, would like to solve another one. Number 2. We have integral e to power x minus 1 over e to power 2x minus 6 e to power x plus 10. So as you can see, we can't, there is no formula here. You can apply. You can even break down into 2 terms, which means we are stuck with this quadratic expression, right? So what we're gonna do? First of all, we are going to substitute the same way. E to power x is equal t, then x is equal natural log t, right? And dx is equal dt over t. Okay, so this is gonna be equal integral t minus 1 t squared minus 6t plus t dt over t. Okay, so the expression that is under under the integral is proper, right? It's a proper fraction, proper rational fraction. Therefore, we can represent it in the form of sum of simple fractions. And we are going to use the same format again. So t minus 1 over t squared minus 6t plus 10 multiplied by 10. It's gonna be equal a over t plus, since here I'm going to have t squared minus 6t plus 10, I have degree 2, that's mean in numerator I'm going to have bt plus c, linear expression. Okay, so, well, we need to find a, b, and c. So, bringing two common denominator, and we are going to get t minus 1, common denominator is going to be this expression, right? Okay, so which means we are going to have t minus 1 is equal a times t squared minus 6t plus 10 and plus bt plus c multiplied by t. All right, so if I combine this, let's say the terms based on degrees, so for t squared, where else I have, oh, I need to bt plus c times t also multiply. Okay, let me go over that one also. I'm going to use method of system of equation. 8t squared minus 12, minus 6at plus 10a plus bt squared and plus ct. Okay, so I have here at squared, bt squared. Since I don't have here on the left side t squared, so coefficient will be 0. So at this point, I'm going to write down a plus b is equal 0. Now, for the coefficient of t, we have negative 6a and we have positive ct. And that's going to be equal coefficient of this t, right, which is 1. And we will get negative 6a plus c is equal 1. And lastly, the available term, what do we have? We have 10a, and that is equal to negative 1. All right, so once you plug these values here and solve it, if 10a is equal negative 1, okay, then a is equal negative 1 over 10, right? So then I'm using a plus b equals 0, which means I will have negative b minus 1/10 equals 0, and b is equal positive 1/10. Yes? All right. Now, and I'm plugging into where c is, 6, negative 6a plus c is equal 1. So negative 6a is going to be positive 6 over 10 plus c is equal 1. This is I'm going to reduce. By 2 is 3, by 2 is 5, right? And I'm going to get c is equal 1 minus 3/5, which means c is equal 2/5. So from here, our original integral with substitution, t minus 1 over t squared minus 6t plus 10 times t dt, it's going to be equal, what do we have, a over t, let me rewrite this, a over t plus bt plus c over t squared minus 6t plus 10. Let me bring this down. Okay. Let me rewrite this 5. Okay. So what do we have from here? Going to put under integral, it's time to put under integral because we already simplified, so we are getting back to integral. So this is going to be equal, we have a negative 1/10, right? So negative 1/10 come out, integral dt over t plus how much we have, bt plus c. B is 1/10 t plus c is 2/5 over t squared minus 6t plus 10 dt, right? So let me, instead of 2/5, I would like to keep it 4/10, right? Multiply by 2 here. If I wouldn't cancel 6/10, I would have it 4/10, which is the same thing, right? So if I would have it 4/10, so this would be equal negative 1/10. This is going to be logarithm t plus, so here is, let me see, my b was 1/10, c is 1/10. Okay, it's going to be plus 1/10 I would take out, and under logarithm I would have t plus 4, right? And in denominator I would have t squared minus 60 plus 10 and dt. Okay, so from here, what would I do here? We have negative 1/10 natural log 10th plus, this will be 1 over 10. Now I'm going to separate, work out this integral, t plus 4 and t squared minus 6t plus 10 dt. That's a nasty integral. We are going to work it out separate. So let's see, integral. Let me write down here on the side so you will know. So integral t plus 4 over t squared minus 6t plus 10 and dt. Okay, what I'm going to do first. First thing, I'm going to complete the square in the denominator. So what do I have here? T to power 2, right? Minus 2 times t, that's mean for the next term it's going to be 3, right? And plus 3 squared, which is going to be 9, right? So we'll be left 1 plus 1. So, and we will get here t plus 4, and underneath I will have t plus 3 squared plus 1 dt. Okay? All right. And from here, I'm going to substitute, and it's going to be u will be equal. See, I'm going through double substitute. That's okay. Then we will come back. U is equal t minus 3. Actually, yeah, it's minus. I kept in mind minus. That's why I was going t minus 3, because it is minus 3, because we have t minus 2t3. Okay, u is equal t minus 3. Okay, and this is gonna give me, let me see, in denominator it's gonna be u squared, right? U squared plus 1, because u squared is going to be equal t minus 3 squared. And for t plus 4, let me see, I need to have t plus 4. So t is equal u plus 3. And we need t plus 4, which is going to be equal u plus 3 plus 4, right? And t plus 4 will be equal u plus 7. So here I'm getting u plus 7 du, because dt, if I take a derivative of dt here, let me see, I'll move it down. Okay, here du, it's going to be only dt, correct? So therefore I have du. All right, so from here I'm going to break down u and 7. It's going to be equal integral u over u squared plus 1 du, okay, plus taking 7 out, and I'm getting 1 over u squared plus 1 du. Yes? All right. So next I'm going to work out u over u squared plus 1. So it's going to be equal natural log, but we need to show it that we'll get natural log. Let me show you step by step here. So I'm going to do another sub here, substitution. Yeah, sorry guys about that. We need to do another substitution so I can show you. So for this one, I'm going to just figure out only this first one, this piece, because with 1 over u squared plus 1, it's already clear, I'll tell you, but I'm going to work out this piece only, this piece of integral, okay? Let me use this color, the one I'm going to work out, all right? So v is equal u squared plus 1, which means dv is gonna be equal to u du, right? Okay, so integral, we are going to get u over u squared plus 1 du, it's gonna be equal, so u squared plus 1, it's gonna be my v, right? My v, and for dv, I need 2u du. Okay, I have u du in numerator. I have u du in numerator. So, which I will need, since I need 2, this is much better what I want to do now. That's what I will do. Since I need 2, I will multiply here by 2, which means I will take out 1/2 also. And I will get, so dv, here is 1/2, dv over v, okay? And using common integral, it's going to be 1/2 natural log v, okay? Let me move this. Natural log v. All right, so let me see. And since we have u plus 7 over u squared plus 1 going back, natural log v, and we know that v is equal u squared plus 1. So this is going to be equal 1/2 natural log u squared plus 1, okay? And that's that piece. Okay, so I'm going to write down here u squared plus 1, and 7 over, now let's do also, this is this piece, it's ready, 1/2, and now we need to work out this piece, right, which is going to be pretty straightforward. So integral 7 du over u squared plus 1, that is 7 arctangent u, because integral of du over u squared plus 1 is arctangent. Let me write down here. Integral du over u squared plus a, right? It's equal arctangent u over a. Okay, since we brought back from v to value u, now we need to go further back from u, get to value t. Our u is equal, here it is, t minus 3. Let me write down, our u is equal t minus 3. So for 1/2 of natural log u squared plus 1 plus 7 arctangent u, we are going to have 1/2 natural log u squared. It's going to be t minus 3 squared plus 1, right? Okay, and I would gladly take off this absolute value because we have their squared, which means there is no threat to get negative sign. Let me see, I'll put this way. Plus 1 and plus 7 arctangent t minus 3, right? All right. So now this simplification I'm going to bring back to our original problem, which is right here. Remember, that's where I stopped and started working out. Look here. I came out to work out. So I'm going to write down 1/10. Let me copy here. And bring and paste here. Okay, let me bring this down. Okay. So 1/10 belongs to this entire expression, so I'm going to put square brackets to protect the common factor, and I'm going to get here, okay, now we continue finishing here, 1/10 natural log absolute value of 10 plus 1/20 natural log. So if I open t minus 3 squared plus 1, I will get back to this quadratic expression we had. So it's going to be t squared minus 6t plus 10 absolute value, and plus 1/10 multiplied by 7, it's going to be 7/10. Okay, arctangent t minus 3 and plus c. Okay, and one very last step. Yeah, that's why integrals consider as a nightmare for future engineers. Now you see why. So, okay, therefore, we remember we here substituted e to power x as a t, right? So we bring back e to power x, and that's it. We will be done. Yeah, I hear you say, yeah, that's it, really. After I solved 1 mile of calculations. Okay, so we are getting, so substituting here, t is equal, not substituting, bringing back. Okay, and the final answer, let me write down with this color. E to power x minus 1 over e to power 2x minus 6e to power x plus 10 dt dx, oops, I already used to d, is equal, so negative, okay, let me write down negative 1/10 logarithm e to power x, okay, plus 1/20 natural logarithm e to power 2x minus 6 e to power x plus 10 hold on. I want to push it down. That's okay. I can clean this and put here minus. All right, and let me make it compact so I can squeeze in the entire expression. Okay. And what do we have here? Plus 7 over 10 arctangent e to power x minus 3 and plus c. And the last thing here, e to power natural log e to power x is gonna be x, right? So let me not to rewrite all this again. I'll just clean this natural log of e to power x. We already know it's equal x, right? I explained above. So this will be x to power negative x to power 10. And let me move this closer. And I am done. Okay, so this is our final answer. I wanted to solve one more free integrals, but I can see this is absolutely enough. So I'll let you go through, digest, and I'll continue in next video. In next video, I will do radicals, how to bring down radicals to fractional rational fractions. Okay? All right. Thank you for watching and thank you for your patience, that's for sure. It's not moving up, so I have to make such scratches so it will move up. Not always, sometimes. All right.